Hello, this is Mingqi Li, and the topic of the presentation I'm planning to make today is design of a hybrid renewable energy system for remote communities in Newfoundland. So in this part, I just want to introduce the general overview about the project. First, I'm planning to make a simple introduction about what place I choose and why I choose to integrate the diesel generator with wind turbine together to make the hybrid system. And the second part, I will make a detailed introduction about the methodology I used in the design of hybrid system. And in the following, I will discuss about the analysis and the results and about what I found during the whole procedure of the designing of the hybrid system. And finally, I will make a general conclusion about what I got from the project and what type of improvement I will make in the future research. So in the following, I'm planning to make a simple introduction about remote Newfoundland communities. As we understand, the remote Newfoundland communities rely on diesel power, so it faces different types of challenge, including but not limited to high cost, high pollution, and unstable situation. But in these places, they used to have rich wind resources. So this is the main reason why I choose to design a hybrid power system by integrating with wind resource. Our purpose of designing the hybrid system is to reduce the levelized cost of energy and power supply reliability. Besides that, we also want to reduce carbon emissions. So based on the previous introduction, I need to select a place that where there is rich wind resource, and besides that, the place should be a remote community in Newfoundland. So finally, I choose Black Tico as my destination, as my research target. And after making some research online, and I got some detailed information about this place. Like for example, until now there are about 91 households, and its annual demand for power is about 1,050 megawatt hour. Besides that, its peak demand is about 237 kilowatts. And in addition to that, we also know that this place, the residents living in this place have to face extreme climate. So it also means that the power supply also face a challenge in the extreme climate. Especially in winter, the temperature could reach negative 30 degrees. In this page, I will make a simple introduction about the data collection. Because in the hybrid system, the main renewable energy is wind resource. So I got the data from Homer Pro about the wind speed in Black Tico. According to the picture shown on this page, we know that it shows that the monthly wind speed during the whole year and in this place. So we know that the average wind speed here is over 7 meters per second. According to that, we know that there is a huge amount of wind resource in Black Tico. Besides that, according to previous introduction, we know that until now in Black Tico, the main power is from traditional energy. So we know that there is a huge potential to develop a hybrid system by integrating with wind resource. So I also make a simple electrical circuit based on my hybrid system, and the system consists of wind turbine, converter, generator, and the battery. So, for example, the wind turbine mainly provide electricity to the to residents, but when it produce more power, it could some of the power will be stored in the battery bank. But as we understand that the wind turbine just produce AC power, but the battery bank only store DC, so converter will play an important role in converting AC power into DC power. And for the diesel generator, when the wind is very small and the power in the battery cannot supply the residence, so the diesel generator will start to produce more power for making compensation for the power gap. So this is our general architecture of the system, and on the left side of the system, and we got the specific detailed component consisting of the hybrid system. After making a detailed analysis with Homer Pro, I got that the configuration is best option for the hybrid system. So the hybrid system consists of 2 wind turbines and 1 diesel generator, one battery, and 1 converter. And on the right side of the page, and it showcases the general diagram that has been shown in Homer Pro. And according to the diagram, we know that the power from wind turbine and the diesel generator is AC power, and the power stored in the battery is DC. So that it's mandatory to need a converter which can realize the transformation between the AC power and the DC power. And besides that, the diesel generator will become provide support to the power supply when there is no strong wind, and at the same time, if the power stored in the battery is enough to support residents, and the diesel generator will also start to provide enough power to meet the requirement of residents. In this part, I'm planning to introduce the control strategy of the hybrid system. So on the right side, it shows the general control diagram. And so the system adopts the Homer circle charging strategy, prioritizing wind power supply when wind speed is insufficient or the battery state of charge is smaller than 30%. The diesel engine is activated to supplement power. The 221 kilowatt converter is used to achieve rapid charging and discharging regulation of the battery. In extreme climates, stable operation is ensured through low temperature heating and strong wind cutout mechanisms. Meanwhile, the minimum operating time of the diesel engine and the management of battery state of charge are set to optimize economic efficiency and equipment lifespan. In the simulation, this strategy achieved a wind power share of 86.7% and a power supply reliability of 100%, verifying its effectiveness under fluctuating loads and climatic conditions. So in this part, I will talk about the performance based on the results I got from the Homer Pro. And on the left side, it shows the general power performance, like the system generates 189,000 kilowatt hour of excess electricity each year. So it shows that the power generation from renewable energy source exceeds the low demand in some periods. So in general, it shows that the hybrid system can meet the demand of the residents during the whole year. And besides that, on the right side, it shows the detailed information about how much power produced in each part. And according to the graph, we know that the power from diesel generator just accounts for 13.3%, while the power from wind turbine accounts for 86.7%. So we know that the penetration of the renewable resource has been improved to 86.7%. At the same time, the carbon emissions will be reduced dramatically. And in this part, I will make a simple economic analysis based on the hybrid system. So on the left side, it showcases the general economic structure of the hybrid system and about how much spent in different parts. And so I got that the total net present cost of this hybrid power generation system is about 13 million US dollars, with the battery energy storage system having the highest cost proportion, mainly due to the initial investment and operation and maintenance cost. And the cost of wind turbine generator and diesel generator are not very high, but the fuel resource cost of diesel generator significantly increase the long-term expenditure. So in this part, I will talk about the stability of extreme climate events. Because in Homer, I can cite the different wind speed range. So in this part, I choose the wind speed from 6 to 20 meter per second to stimulate the system performance under different extreme climate scenarios. So the analysis results show that at low wind speed, like 6.84 meter per second, the operating time of the diesel engine increased by 43%, and the fuel cost rise significantly, and the system stability decreased under strong wind conditions like 20 meter per second. Although the penetration rate of wind power reached 87.9%, the annual throughput of battery soared by 56%. So the energy system faced a severe test. And besides that, according to the previous page, we know that the cost on the battery used to be more expensive. So when the system faced high wind speed, like 20 meter per second, and the general cost of the system will increase dramatically. So it's particular worth noting that the 200 kilowatt diesel engine plus wind power hybrid solution at the wind speed of 12 meter per second demonstrates the best balance. And the picture on the right side showcase that for the different of the system performance under different wind speed. So I will make a conclusion through Homer Pro modeling and optimization. The system was figured with two 200 kilowatt wind turbines and one 200 kilowatt diesel generator and a 16 megawatt hour energy storage battery. The results show that the annual power generation of the system is over 1 million kilowatt hour, so it can fully meet the community's annual demand. And there is no power shortage too. At the wind speed of 12 meters per second, the levelized cost of energy is 0.91 US dollars per kilowatt hour, and the power supply reliability is close to 100%, significantly reducing diesel dependency and carbon emissions. Although the energy storage system faces a challenge under extreme climates, this system also provides an economic, reliable, and environmentally friendly energy solution for similar remote areas and has significant promotional value. So in this part, I'm planning to introduce the further future work, like what type of the improvement I can make in the future. So the future research can further explore the application of new phase change materials in battery insulation in extremely cold regions and the development of hybrid system optimization based on predictive control to continuously improve system performance. And besides that, we also know that according to the previous pages, we know that the cost of battery used to be the highest one. So I hope in the future I can also focus on the battery to make some more creation so that it can decrease the cost of the money spent on the battery maintenance and operation. So for this part is the reference. It's a reference about the report. Thank you.